Welcome to our video for adding and subtracting fractions with unlike denominators, which means if you have a number a over b and you're adding it to c over d, in general, this is totally general, then b and d don't equal each other, right? So we can say that it's going to be bd over what? Over ad plus cb. And that might seem really confusing, but I'm going to go over that in another video. The details of what I'm saying here, you might want to, I'm going to leave it to you to kind of think about what I'm talking about here. But basically, I'm just going to say that we have two fractions or more where the denominators are different, right? There has to be a way to combine them. So what do? Well, in other videos, I go over the reasons about why our procedures work, right? Why we have certain strategies. Here, I'm going to just use those procedures with a little bit of commentary about why they work. So if you want to go back and review more about the question of why are these rules working the way they do, please go back to some of the other videos I have on this topic. Okay, so what do we have here? Well, a 6th grade class completed a survey about favorite foods. Of the students in the class, 2/6 chose hamburgers and 3/8 chose pizza. Excuse me. What fraction of the class chose either hamburgers or pizza? So they want us to add, right? Because they want to know in either group what was chosen. And so we have 2/6 and 3/8. Well, 6 and 8 are different denominators. One of my first steps is to reduce. So 2/6, to reduce that, I'm going to divide both numerator and denominator by 2, because 2 is a factor in both numbers, which, in other words, 2 times 1 is 2 and 2 times 3 is 6. And that's going to help us, right? We want to reduce. So what do I get? Well, 2 divided by 2 is just 1. That's right here. Okay, that's done. And 6 divided by 2 is 3, so that's done. So we have 1/3, which is 2/6, and you can almost see it right here. They're the same thing. 1/3 plus 3/8. And I know I'm done reducing 3/8 because the only factors of 3 are 1 and itself, it's prime, right? There are no factors that 8 and 3 have in common. And there are no factors that 1 and 3 have in common. There's a fun way of saying that called relatively prime. In other words, 3 and 8 are relatively prime. I spell that, relatively prime. There we go. 3 and 8 are relatively prime because they have no factors in common. Just like 1 and 3 have no factors in common. That's how you know you're done reducing a fraction. So what do we do here? Well, I want to look at 3, right, and 8, and say, well, what do they have in common? That's kind of what I was doing here with BD. A shortcut could be just to multiply 3 by 8. Because when you multiply these two, you'll create a multiple of which they're both factors, right? Because if 3 times 8 makes 24, we know 8 and 3 both go in to 24. And in fact, I'm going to use it. I think that's the least common multiple. So 3 times 8, or up here, or b times d, which is 24. And then, well, I can't just add 1 plus 3 because I've rescaled these fractions. So instead of 1/3, I'm going to have what? Well, I'm going to multiply 1 by 8 and 3 by 8. That's how I get 24. And then we'll multiply 3 by 3 and 8 by 3. Essentially, that's just multiplying by 8 and then dividing by an 8, because everything in the denominator is what we're dividing by. So I'm not changing these fractions. I'm just multiplying by 1. 8 and then over 8. 3 and over 3. I'm not changing anything. So 1/3 becomes, well, 3 times 8 is 24, and 1 times 8 is 8. So 8 over 24 is equal to 1/3 plus, well, here we have this almost the same thing, just that now it's 8 times 3 is 24, and 3 times 3 is 9. So now when I add these up, I add across. It's kind of my catchphrase for myself. So I add 8 plus 9, but really we're counting the number of 24ths that we have, the number of these. How many do we have? Well, we have 8 here and 9 more there, so we have 17 24ths. So we don't add the denominator. And 17 over 24 is our answer. Let's look at one more. Here, Mr. Miss Brown asked her students to simplify the expression below. What is the simplified version of Miss Brown's expression? What they mean here, simplified version, if you combined these fractions into one fraction and reduced it, what would you get? I think they mean that at least. They might not mean the reduction part, but we'll see. So 2/3. What's an equivalent fraction for 2/3 that's in terms of fourths? Well, 3 and 4, that's two different numbers, both have a multiple of 12 because 4 times 3 is 12 and 3 times 4 is 12. So I'm going to rewrite this. 2/3 multiply both numerator and denominator by 4 because I want to get 12 as the common denominator. So I get 2 times 4, which is 8 over 12. And then 1/4, let's change that one, 1 over 4 times 3, and then denominator times 3, gives us 3 out of 12. And we're adding them up, right? We're adding up our twelfths. So here I have 8 twelfths, and here I have 3 more twelfths. Altogether, I'll have 11 twelfths. So our answer here is D, 11 twelfths. All right, I hope that helped.